Welcome to this tutorial video in which we'll be examining distance and displacement. We'll start by looking at what are scalar and vector quantities, and then we'll look at some worked examples. So first of all, scalar quantities. Scalar quantities are measurable quantities that are described by magnitude and also a unit of measurement. So for example, a Mars bar's energy content is 694, that's our number, kilojoules, the unit of measurement. Likewise, the temperature of the human body is 37, that's our number, degrees Celsius as a unit of measurement, and so forth. A lot of quantities are, in fact, scalar quantities. Another classification of quantities measured would be that of a vector quantity. Now, vectors use both a magnitude, that is a number, and a direction when they describe a quantity. So, for example, your weight force might be 800 newtons downwards. In that description, you'll distinguish a number, a unit of measurement, and a direction. The velocity of a car, for example, could be 80 kilometers per hour in a northerly direction, or the acceleration of a Formula 1 car could be 11 meters per second squared forward. Each of these examples provides a number, a unit of measurement, and a direction. Let's examine now specific cases of distance versus displacement. First of all, distance is a scalar quantity. It describes the amount of ground an object has covered during its motion. Whereas displacement is a vector quantity. It describes how far out of place an object is in terms of both the magnitude and direction. Let's examine a really simple example. So in this example, we've said consider the journey driven, shown below in purple, by James one Sunday afternoon. So we can see the purple journey that James has travelled from his starting location. He's wound all along this map, and he's got a total distance of 180 kilometres. However, if we're asked to look at James's displacement, which is in simple terms as the crow flies from a start and a direct shortest route to the finish, James's displacement from that 180 kilometre journey is actually only 100 kilometres in roughly a southeasterly direction. So hopefully this emphasises the difference between distance and displacement. Now let's examine a sample problem. Consider the following journey of a postman during a particular delivery. In turn, the postman travels 5 kilometres east, then a further 2 kilometres north, a further 9 kilometres west, and finally a further 8 kilometres south. The tasks we have to complete are 1. Draw a scale diagram of the journey, 2. Calculate the total distance travelled, and 3. Calculate the postman's displacement. So task 1. Draw a scale diagram of the journey. When we're doing scale diagrams, we need to have a reference point, and generally that's presented with the north, south, east, west cross with the direction of north shown. So the steps were from a starting position, X being position and I being initial. Postman has travelled 5 kilometres east, 2 kilometres north, 9 kilometres west, and 8 kilometres south. So to work out step 2, task 2 the total distance travelled, you simply add the 5 kilometres plus the 2 plus the 9 plus the 8, which gives you a total distance travelled of 24 kilometres. Distance travelled is quite a simple calculation. Now finally we're asked to calculate the postman's displacement. Displacement compares a finishing position against a starting position. So in that sense we've started here at xi, the initial position, and at the end of the day the displacement travels all the way down to xf, the final position. It's true the postman has travelled this blue journey, but in terms of as the crow flies looking from above, he started from this position and travelled all the way to his final position. Now we just need to use a little bit of mathematics to answer our question about the postman's displacement. First of all, let's consider that delta x, which is our displacement, as one right angle triangle. You can see we've got an 8 kilometre south distance here, and if I subtract the original 2 kilometres heading in the northerly direction, my true displacement in a north-south component is from here to here. Okay. Also, when we take our 5 kilometre east away from our 9 kilometre west, that means our true east-west displacement from start to finish is from here to here. Let's work out these values. So simply, the 9 minus the 2 gives us a displacement of 6 from start to finish in the north-south plane. And our 9 minus our 5 gives us a 4 kilometre displacement in an east-west direction from the start to the finish. Now, if we use some simple Pythagoras, the equation being c squared equals a squared plus b squared, on this red right angle triangle, we can see the hypotenuse, which is our unknown delta x squared, will be equal to 6 squared plus 4 squared. So you follow your mathematics through, that gives us 36 plus 16, a total of 52. And when I take the square root of the 52 to get delta x by itself, the unknown hypotenuse of this right angle triangle, I find the total displacement to be 7.2 kilometers. However, we said earlier that all vectors require a magnitude, a unit of measurement, and a direction. So we need now to find out our angle, our theta. Now, using simple geometry, again with this right angle triangle, this angle theta has an opposite side length of 4 kilometers and an adjacent side length of 6. So when we use our basic trigonometry, opposite over adjacent is a tan function. We substitute in our numbers. Our opposite value is 4 kilometers. Our adjacent value is 6. To get theta by itself, I take the inverse tan of 4 on 6 and I get 33.7 degrees. So my final answer for the displacement of the postman is 7.2 kilometers south, 33.7 degrees west. It's important to recall that our angle or direction of displacement references from the start. So our initial position, you can see that this track, this dotted line, is indeed in the southern hemisphere of our grid. It's not above in the northern, it's in the southern. And from the south direction, it's heading towards the west. And that angle was 33.7 degrees to the west. So again, our final displacement value for this postman's journey is 7.2 kilometers south, 33.7 degrees to the west. I hope this tutorial has been useful and helps clarify the differences between distance and displacement.